let's continue with some examples of using synthetic division. As a reminder, all of it is spelled out right here as far as synthetic division is concerned. Let's go to the next page, and there's an example at the top of the next page of using synthetic division. All right, we're asked to divide this third-degree polynomial by this linear divisor. I can use synthetic division. And remember that the alternate forms of writing a division problem could be in a fraction situation. Okay, so we want to divide. You can do long division if you want. Okay, but what I'm going to do first is I'm going to go to the coefficients of the cubic. So I've got a 1 here, so I'll put 1 here. I have a 0x squared term that I need to fill in, so I'll put a 0. Remember, with synthetic division, we leave out all the variables, the letters. We're just focusing on numbers. I'm going to put -7 and I'm going to put -6. Okay, what's the number that goes outside here? Well, the divisor is x minus 1, so the 0 is +1. So what do we do? Well, we drug this first number and put it underneath this line right here. Then we start multiplying. 1 times 1 is 1. Line it up underneath the next free digit, the 0. Add down, we get 1. 1 times 1 is 1. Add down, don't forget your calculator, -6. -6 times 1 is -6. We add down and we get -12. All right, but remember we want to report Q of X and we want to report R of X. So think about, and I think what's helpful is that we should write down over here that this is a third-degree divisor. And so all of these coefficients will be part of, or these numbers will serve as coefficients for a quadratic quotient. Remember, this last number is your remainder. So I'm going to come over here. Our quotient is 1x squared plus 1x minus 6, and the remainder is -12. And you could put that over the divisor of x minus 1 or not. It's certainly up to you. All right, let's go practice a couple more synthetic division problems on our practice sheet. We'll only practice a couple, and then of course you can look at the worked out solutions if you want to attempt some of the others on your own. First of all, by inspection, when it tells me to divide using synthetic division, I first want to make sure that all the divisors are of the linear form, and they are. Let's see. I was looking for one that was missing some terms. I think I'll start with 8 and then maybe do 9 and leave 5, 6, and 7 for you to practice if you need it. All right, I want to divide this 5th-degree polynomial by this linear divisor. So I notice, first of all, that x minus 2 is the factor, so I'm going to use 2, okay, outside here. I'm going to go back and grab the coefficients. So I have a 6. Notice that the 4th-degree term is missing, so I have to fill in a 0. The 3rd-degree term is present. I use its coefficient. Second is 4, and the rest of them are there. I kind of skip a little space, and I draw a line here. Bring down the 6. Then start the multiplication. It's 12, add down. 12 times 2 is 24. Add down is 22. That product is 44. That becomes 48. 48 times 2 is 96. This becomes 93. I think 93 times 2 is 186. And so I get 187. So this last number, remember, is your remainder. So again, this is a 5th degree. And then the answer, the quotient, is going to be a 4th degree quotient. So start with the 6. X to the 4th, etc. We should end up with the constant and then our remainder. I'll put it over the divisor of x minus 2. Okay, and then I think I'll do number 9. And then leave the other 3. So if you feel comfortable, I would just say pause the video and just, work them out on your own and see how you do. Okay, I'm going to put the divisor, -2, gives me that 0. I have a coefficient of 1. The 6th degree term is missing. I've got the 5th degree, it's a 1. The 4th degree term is missing, that's a 0. And I've got 3rd degree, oh goodness. The 2nd degree term is missing, that's a 0. The linear term with an exponent of 1 is missing, and I've got a 12. Ooh, I'm probably going to run out of some room here. Remember, these are coefficients of a 7th degree polynomial, so all these will be coefficients of the 6th degree, excluding the last number, which will be your remainder. So bring down the 1, it's -2, add, multiply, 5, -10, add down is -10, that product is 20, add down, that's 10, that's -20, add it to a 0, that becomes +40, I get a 40 here, 40 times 2 is -80, and so when I add here, I think that's going to be -68. So that's our remainder. And then these right here will become the coefficients of your 6th degree quotient. So this is n is 7, and these are coefficients of the 6th degree answer. Not very friendly. One other point to make is that in neither problem 8 nor 9, x minus 2 is not a factor of this 5th degree polynomial because my remainder was not 0. Likewise, x plus 2 is not a factor of this 7th degree polynomial because my remainder is not 0. Right, so that's synthetic division. That's probably a little bit better than, not using it, because then you have all those x's in there, and that problem could probably take up almost a whole, sheet of paper. Okay. So let's move on to the next objective then. So back to our paper here. Okay, so far we've seen long division, and we've seen shortcut, synthetic division, that has to have certain conditions, of the divisor before we can use it. And the next topic is the remainder theorem. It says a lot of words and variables here. If a polynomial is divided by x minus c, a linear factor, then the remainder is f of c. It says, consider the above example. This polynomial up here was divided by x minus 1, which is in that linear divisor form, x minus c. So the remainder, this -12, will be the same value as the function, the original problem, evaluated at c. Meaning if I took 1 and I plugged it in for all these x's, I should end up with -12. That should be my remainder. The remainder theorem says right here, this is the remainder. Another way to get this remainder is to just plug in 1, +1, into the function, and we should get the functional value to equal the remainder. So we have a check on it. So if I take the function and I plug in 1, not -1, but plug in 1, and I replace each x with 1, and I do the work on my calculator, I do end up with -12. It's kind of a quick way to check to make sure your remainder is correct if you're dividing by a linear divisor, by plugging the c value in and seeing what you should get right here. So that's called the remainder theorem. We're going to use synthetic division to get the remainder, or what we call also f of c, or the functional value. So let's go back to our practice sheet, and I think it's on the next page. Yes. We have a couple of problems. It says, use synthetic division, got it, and the remainder theorem to find the indicated function value. So in problem 10, we have a cubic. It wants me to find f of 3. Well, if I'm doing this problem, I'm just going to plug in 3 for every x. This is not what I'm supposed to be doing, but this is one way to check my work. I'll go to my calculator, and I've got that answer somewhere. F of 3, pardon me, is actually going to be -27. If you did all these computations on the calculator, you're going to get -27. Okay, I found the function value. I found the y value. That's what value means by just plugging in 3 to that function. But that's not what they want me to do. They want me to use synthetic division to get this as my remainder. So I just kind of do this to check my work. All right. So if I'm going to use synthetic division, the number that goes out here is not -3. It's actually this value right here. It's not in this form. Ugh. It's not in the factor form, x minus 3. Okay, it's actually been extracted. So I'd put 3 here. So if you're coming from a factor, you have to take the opposite sign. But if it's written in this notation, you actually literally take that number. All right, let's put the coefficients here of 1, -7, 5, and -6. There's no placeholders necessary. Okay, and not that we need it for this question, but this is a 3rd degree polynomial. Bring down the 1, multiply, -4, -12, add, -7, -21, add, I get -27. So had I not done all this work right here and jumped into synthetic division, then I would have saw that my answer is -27, which means f of 3 is equal to -27. And this is the work that supports this answer. I was just checking here. All right, same thing over here. What is the functional value? Well, again, I'm going to plug in 2 for all these x's right here just to kind of see what my answer should be. And I actually get 0. Okay, so that means when I go to synthetic division, my remainder should be 0. I don't think I need any placeholders. 4, 3, 2, 1, yep. 1, 2, down, -1, -2, 3, that's 6. Yep, I get 0. So I would say that f of 2 is equal to 0. They want me to find f of 2, not this way by plugging it in, but by using synthetic division. That is our remainder theorem. Okay, let's go back to our notes. We have a couple more objectives here. Actually, just one, I think, with a couple practice problems. All right, so that's the remainder theorem with synthetic division to get a functional value. Okay, factor theorem. It says, if f of x is a polynomial and we get a remainder of 0, then we've already mentioned that x minus c is called a factor of that polynomial. And conversely, if x minus c is a factor, then we know the remainder is going to be 0. All right, let's use the factor theorem. So here's our question. Let's see if we can kind of read through this and see if it directs us what to do. All right, using the factor theorem, find the zeros of this polynomial equation. So we've found zeros before by letting y be 0 and factoring or using quadratic formula. We've found zeros multiple ways before. But it says find the zeros of this polynomial equation, not by factoring, but given that x plus 2 is a factor. It says because x plus 2 is a factor, you know that from the factor theorem that the opposite, the 0, -2, gives us a remainder of 0. All right, so we know that x plus 2 divides into this cubic evenly. We're going to use synthetic division to find the other factors. Okay, so to find these zeros, we already know that -2 is a 0. We have to find the other ones. So let's do this. Let's go ahead and use synthetic division with a -2 outside here. Let's grab the coefficients. Let's see what our quadratic quotient is going to be. Remember, this is 3rd degree. So let's use synthetic division here. I should get a 0 or I made a mistake. Yep. Which means if this is the remainder, these are the coefficients. Let's put this into a quadratic. So x plus 2 divides into this cubic, leaving this quotient. Okay, but if we want to find the zeros of this quadratic, that's part of this cubic, I would set the quadratic equal to 0. All right, so let's go back to, did we ever learn how to solve quadratic equations? Finding their zeros? Yeah, we did. You can go straight to the quadratic formula since you have a 2nd degree equation. You can go right to the quadratic formula. It doesn't tell us that we have to use factoring or the quadratic formula. I might do factoring just as a review. Or you can go right to the quadratic formula to find the other two solutions. So, okay, this is telling us that we're going to have at most two solutions. If you have a cubic equation, you're going to have at most three answers or three solutions or three zeros or roots or whatever. Let's factor this. I'm going to factor by grouping because a is greater than 1 in this quadratic equation. So I need a factor sum chart. Factors of negative 24 that sum to negative 10. Because I want a product that's negative, one of the two of the numbers in the factor sets have to be negative. The larger number should be negative. So let's go down here and make all the larger in the pair of factors negative. And when we go back and add them, I see that right here, 2 plus negative 12 is negative 10. So let's go over here and group. So we've got 3x squared. I'm going to put the minus 12x first and the plus 2x last because these collect to negative 10x. And I like the negative up first. And then I bring down the minus 8. And don't forget your equal 0. And because I have a plus sign here, I don't have to worry about making the mistake of making the adjustment here. Common factor, 3x leaves x minus 4. Common factor of 2 leaves x minus 4 equals 0. Because we're not just factoring, we're solving, and we need that equal 0. And what, x minus 4 leaves 3x plus 2. Set each factor equal to 0. And so from this factor, the 0 will be when I add the 4 to the other side, the opposite, or 4. That's another 0. And then the same thing here. Subtract the 2 first to the other side and divide last. So 3x equals negative 2, divide by 3. So the other 0 is negative 2/3. If you chose to use the quadratic formula and you did everything right without making a mistake, you would get the same solutions as well. I think sometimes the hard part of quadratic formula is at the end, you've got to kind of simplify those two different, solutions with that plus minus, and it might get a little confusing. All right, so let me go back and make sure I answered the question. It says, find the zeros of this polynomial equation given that x plus 2 is a factor. I did synthetic division to go from a cubic to a quadratic. I should have got a remainder of 0. I rewrote this as a quadratic and then insert my, skills of solving a quadratic equation. So, yep, I did. So my 3 solutions, I really probably should come over here and label them. So my zeros. So I have 3 of them. They gave me one by saying that x plus 2 is a factor, and that was negative 2. That's the smallest. And then negative 2/3, and then positive 4. All right, so let's go back to our practice problems. Okay, and let's look at 12. Use synthetic division, got it. To divide this cubic by x plus 1, use the result to find all zeros of f. Okay, so it must be that x plus 1 is going to be a factor. It must be that I'm going to get a remainder of 0. So I'm going to put negative 1 up here. And it looks like I don't need to put in any placeholders, so we're good. Remind yourself that these are the coefficients of a cubic, so these will be coefficients of a quadratic, except for the last number, which should be a 0. If x plus 1 is a factor, I should get a remainder of 0. If I don't get a remainder of 0, then I can't, solve that quadratic. I need a 0. Yep, I got 0. If you think you should be getting 0 and you're not, just go back and use your calculator. It's probably just a little sign mistake. All right, so this is due. So I'm going to come over here and start my list of zeros. X equals, I'm going to have at most 3 zeros. The degree tells you at most how many zeros you might have. So first of all, I know -1 gave me a remainder of 0, so that is one of my solutions. These are the coefficients of a quadratic, so x squared minus 3x plus 2. Let's set that equal to 0. I'm going to factor. You can use quadratic formula, but this should be an easy factor because a is 1. So factor sum chart of 2 sums to -3. The only choices are -1 and -2. So no grouping, go straight to the multiplication problem. X here, -1, and x minus 2. So from this factor, I have a 0 of +1, and from this factor, I have a 0 of +2. So add the 1 to the other side, etc. So my other zeros are 1 and 2. So the first 0 came from that factor. All right, let's take a look at the language of 13 and see if it suggests what we should do here. Solve the equation. 2x cubed minus 3x squared minus 11x plus 6 equals 0. Solve the equation means find the zeros. Given that -2 is a 0 of that cubic. Oh, okay. So x equals -2, already, they're telling me, is a 0. I'm going to have at most 3 zeros, so I might just kind of get ready. Solve this equation, -2 is a 0. Well, let's use synthetic division. It didn't tell me to use synthetic division, but now that I've learned it, this language of this problem is suggesting that that's what I should do without directly telling me. So -2. If -2 is a 0, remember, we should get a 0 here. If we don't, we made just some computation mistakes. 2 goes down. Yep, that gave us 0. So these coefficients represent the coefficients of a third degree when you divide one time. When you divide x plus 2 into a cubic, you're going to get a quotient that's quadratic. So this is n equals 2. Let's grab these. So 2x squared minus 7x plus 3. This is quadratic. Let's find the zeros. Set it equal to 0. Let's find the zeros. Again, your choice is quadratic formula, or factor by grouping. I think I'll just do factor by grouping. 2 times 3 is 6. I want -7. Both factors need to be negative to multiply and give us a +6, but add to a negative. So it looks like it's going to be this first set right here. And because these are both negative, it doesn't matter what order. These two will collect back to the -7x, bring down the +3, and don't forget your equal 0. I'm at that subtraction sign. You're going to put a parenthesis, so you got the 6x. Don't forget to make the adjustment to a -3. X will come out here, leaving 2x minus 1. 3 will come out here, leaving 2x minus 1. And we're in good shape here. We've got the same parenthesis, same factor that we'll pull out, leaving x minus 3. Don't forget your equal 0. Set each factor equal to 0. So I'm going to add a 1 here and add a 1 here. So 2x equals 1, divide by 2, divide by 2. So I have a 0 of x equals 1/2. And then here, from this factor, x minus 3, we get a 0 of +3. Right, so in this section, chapter 3, section 3, we learned about dividing polynomials the long way. All right, and then we learned about using the shortcut method for dividing polynomials as long as our divisor is of the linear form. We couldn't do division with an x squared or x cubic. Then we learned about the remainder theorem, and it's just really, the remainder theorem is just using synthetic division to get the last number. That's what we call the functional value. And then we also looked at the the factor theorem, which kind of helps us with the language of a question using synthetic division to find all the zeros of a given polynomial.